All right, so welcome back to the second video here that's going to go along with normal distributions and the empirical rule. So we talked about normal distribution, and here we're going to look at two sets of data that are approximately normal. The more data you have, the more likely it is to fall within a normal distribution. And here we're just going to do some practice. I'm going to do this first one out, and then I want you to actually try the second one on your own before I do it. So I'll remind you to pause and try that one on your own. So what we're going to do is we're actually going to first find the information. So up here is a reminder, we were using the 17 and the 2.6 to find what is our mean, and then what are these kind of cutoffs here. So that's the first thing we're going to do based on the information given. So here it says we have the dot plot showing the scores of 50 students on the algebra test. The mean of this is 76.4. So the first thing I need to come in here is figure out where is 76.4. Well, if this is 70 and this is 80, this means 72, 74, 76. So my mean is going to be approximately here. The next information then it gives me is my standard deviation, which we know is approximately how spread out is my data. 7.9 is kind of high for a test score, but let's see how this kind of plays out in this case. So when we're looking at normal, we said our mean's going to be about in the middle, and we do look. This does look to be about the middle of all of my data. And then we're going to do one standard deviation in either direction. So the first thing that I'm going to do is I'm going to choose the 76.4. I'm going to add that 7.9, and that gives me 84.3. So I'm going to come up here, I'm going to try and figure out where is that 84.3. Well, this is 80, so this is 82, 84. 84.3 is going to be approximately here. So it's going to be my first cutoff. This is one standard deviation away from the mean. But I can also go in the negative direction. So I'm going to do a very, very similar thing, and I'm going to take that 76.4 and I'm going to subtract that 7.9, and that's going to give me 68.5. So I'm going to do a similar thing and try and find that. So if this is 60, 62, 64, 66, 68, oh, the 68.5 is kind of right here. So if this is 68 and 70, that guy's probably 69. So I'm going to draw my line right between those two. And this is -1 standard deviation. So what I actually filled out here was my mean plus or minus 1 standard deviation. So this was 68.5 to 84.3. Now, the next thing it wants me to do is it wants me to determine what percent of my data falls within this one standard deviation. I know there's 50 total students, so I'm going to count out how many of these I have. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. So 33 of my 50 students scored within this first standard deviation. And if I put in my calculator, I can see that that is 66% of my data. And that's kind of what we see here. That is 66 is a large percent. And so that's what we would see here. That's the first step that we did. But now we got to do 2 standard deviations away. So I'm going to take these numbers, which are my bins right here. Sorry, I'm going to take these numbers, which are the edges of these right now, and I'm going to add or subtract that standard deviation again. So I'm going to take 84.3 and I'm going to add that standard deviation of 7.9 again, and that gives me 92.2. And I'm going to go in the other direction, so 68.5 minus 7.9, and that gives me 60.6. I'm going to do the same thing. I'm going to find where those are. So if this is 90, this is 92. I'm going to go ahead, I'm going to do the percent, so I'm going to count how many of these there are here. So this was 33. There's now 1, 2, 3, 4, 5, 6, 7, 8 here. So I'm going to be able to come back and use that number. And then my other bin was 60.6. So if this is 60, this is 62, that guy would be a 61. Let's go right on the other side of him. So this is going to give me 1, 2, 3, 4, 5, 6, 7. So now when we're saying the data that falls within 2 standard deviations, we're saying everything from here to here. So we're including the stuff in the middle because that's still beneath it. So we're including all of these people. So I'm going to do that 33 plus my new 7 plus my new 8. And that gives me 48. So 48 of my 50 people fell within 2 standard deviations of the mean. And when I put that into my calculator, I find out that that is 96% of my students fell within 2 standard deviations of the mean. But then you'll always have your students that are a little bit further away. And so let's do this last standard deviation, this third one out here to the side. And so once again, I'm going to take these numbers that we have over here, I'm going to add and subtract that standard deviation one more time. So 92.2 plus 7.9. Oops, sorry. And I'm going to do 60.6 minus again, and that's going to give me 52.7. So I can come in and I can find those. Well, 100 is obviously a little bit above here. And I have 1 in this guy. And then 52.7 is going to be right around here. And I have 1 person here. So if I now look from this pink line all the way to this pink line, all of my data falls within that category. And for data that's approximately normal, that's going to happen a lot, that all of your data is going to fall within 3 standard deviations of the mean. So notice the majority of our data was within this 1 standard deviation from the mean. Then if we went 2 out, we caught a little bit more. And then when we went to the third one, we caught just those stragglers. So this is what it looks like to kind of find the percent of data that falls within these standard deviations. So once again, for this one, I'm going to scroll it up. I would like you guys to actually pause. Actually, I'm going to stop the video and do another one. But I would like you to try this problem on your own before coming back and watching the next video.